Good afternoon. Uh, Welcome to my class. Today's chapter subject chemistry, chapter 4 periodic table, topics periodic properties, and also other some topics. Today is the last class, and then exam will be held on this chapter on 31st August at 7:30 p.m. Okay, this is the fourth online exam in chemistry. This one will be held on 31st August at 7. Okay, look at this periodic table. Our chapter name is periodic table. Okay, this periodic table, look at this left hand side. There are 118 elements in this periodic table, and we know this left hand side, these elements are metals, right hand side elements are non-metal. If we move from left to right, non-metallic properties increases. If we want to move right to left, metallic properties increases. This change from left to right or right to left and top to bottom, bottom to top, this changes properties of elements. This trend is called periodic property. Today's topics is periodic properties. The properties which are directly or indirectly related to their electronic configuration and show gradual change when we move from left to right in a period or from top to bottom in a group are called periodic properties. Periodic properties are ionization energy, electron affinity, electronegativity, metallic character, nature of oxide, and also atomic radius. These things I taught atomic radius last class. Look, ionization energy trend, atomic radius trend, ionization energy from, if in a periodic table like this is a periodic table, if we move from left to right, ionization energy increases, electron affinity increases, atomic radius top to bottom, atomic radius increases, left to right, right to left, atomic radius increases. So here this element will be biggest, this one. Here atomic radius bottom and right, this one. Okay, electron affinity increase from bottom to top, electron affinity increase from right to left, left to right, ionization energy increase. Okay, non-metallic character, in non-metallic character increase this way. So this one is top non-metallic, and metallic character increases from left to right, and this below, this one will be here metallic character more. Definition of ionization energy. Look, this is not ionization energy definition. Okay, look at this picture. Look this picture in the nucleus. Here protons contain and neutrons contain, and shell, first shell, how many electrons? 2 electrons, and second shell there are 1 2 4 electrons, and here second shell, this is 2 shell containing atoms. So outer shell, outermost shell is this one, second shell. Here is 1 electron is removing. To remove electron from the outer shell, required energy. If we want to remove energy required here, if we want to remove electron from an atom in the gaseous state, to this energy is the required energy is called. If we want to remove electron from outer shell, need energy is required, energy is needed. This needed energy is called ionization energy. So this definition, ionization energy definition, is the amount of energy needed to remove the least boundary electron from a one molecule of gaseous atom is called ionization energy. You give this definition: the amount of energy needed to remove electron from m mole of gaseous atom is called ionization energy or ionization potential. Ionization energy and ionization potential is same. The amount of energy needed to remove electron to form one mole of gaseous atom is called ionization energy. So what will be definition? The amount of energy required to remove here given least tightly bound electron from a molecule of gaseous atom is called ionization energy. Khadija want to জয়েন্ট করতে পারতেছে না। আমার এটা কি করতেছে একদম এটা কাঁপতেছে কেন এখন একদম আচ্ছা তো in the shell, outer shell, okay, this is the nucleus. Okay, like sodium how many electron? Hello students, sodium how many electron do you know?
It's 11.
11.
Okay, electronic configuration is, what is configuration? Only shell, not subshell. I am drawing electronic configuration using Bohr's model. So here is a 11 electron, sodium 11 electron. So electronic configuration will be 2. What will be 2? Next, two eight one only shell. If you want to say using electronic configuration subshell orbitals, you have to have 1s2 2s2 2p6 3s1 or only shell 281. Okay, so here is a inner shell is 2 electrons and inner shell, and second shell is 8 electrons. This is also electronic configuration. This electronic configuration is given here using Bohr's atomic model. Bohr's atomic model, we know shell. There is a shell. This second shell is okay, and in the outermost shell is 1 electron. Okay, so this if I want to remove this electron, energy is required, energy is needed. This needed energy is called ionization energy. So when a atom in the gaseous state, not in the, I know, so atom sodium is solid, but here you at first you convert sodium into gas. When in atom in the gaseous state, the amount of energy required to remove one electron to form one positive ions in the gaseous state, the energy required to form one again, the amount of energy required to remove one electron from one molecule of gaseous atom to form one positive charge in the gaseous state is called ionization energy. Okay, so ionization energy definition we have understood. Ionization energy. So what will be ionization energy? একটা যদি ইলেকট্রনের খুব অ্যাট্রাকশন থাকে, এটা ionization energy কম হবে না বেশি হবে? If the electrons it's not eager to remove electrons, and some like atom is very easily can be removed. What like two atoms, one atom like two atoms, one atom has needed one atom is easily, one electron can be removed from one atom easily, and another atom electron cannot be removed easily. Where ionization energy is more, first one or second one? Like one atom we can remove easily electrons, so here easily, so less ionization energy. If we remove difficult needed, so more ionization energy is required. Okay, I am doing these things. Take a screenshot someone today's attendance. Take a screenshot. Okay, ionization energy, the energy that is required to transform an element into 1 mole positive ion, removing 1 mole of electron from its 1 mole of atom in its gaseous state, is called ionization energy of that element. You write definition from here. It is a periodic property. In the same period, elements of the left side have greater left hand side. Left hand side elements have greater radius than those of the right side. When atomic radius is less, ionization energy is greater, and vice versa. So if the small size, this is atomic size from left to right decreases, left to right decreases, or from right to left increases. So ionic radius is greater, ionization is smaller, because we can easily remove. And if atomic size is smaller, ionization energy is greater, because here electron is tightly bound. Attraction between electrons and nucleus is more. For attraction more, so easily electron cannot be removed easily, so more energy is required. Here electron can be removed easily because the atomic radius is more atomic radius, so radius distance is more, so attraction between electrons and nucleus is less, so easily can be removed electrons, so ionization energy is less. So when atomic radius increases, we left to right to left, so ionization energy decreases. Here also ionization energy top to bottom ionization energy decreases, because top to bottom ionization in a periodic table, top to bottom ionization energy decreases because atomic radius increases. So in the same period, elements of the left side have greater radius than those of the right side. When atomic radius is less, ionization energy is greater, and vice versa. When that means opposite, when atomic radius is more, ionization energy is less. So here one atom electron is removed This is lithium 2 1, this electron removed, so it become 2. This is 1, this atom lithium atom become lithium 1 positive ion. The amount of energy is required to remove this element. This required amount is energy is called ionization energy. The ionization energy of silicon is greater than sodium, magnesium, aluminum, because the atomic radius of silicon is smallest. All this element. On the other hand, sodium having the biggest radius, them is endowed with least ionization energy. Okay, of the alkali metals, group 1, lithium, sodium, potassium, rubidium, cesium, francium, lithium. Which one is the smallest size? Lithium, sodium, potassium, rubidium, cesium, francium. In group 1, which one is the smallest atomic radius? Among lithium, sodium, potassium, rubidium, cesium, which one has the smallest radius? It removed. Okay, this lithium, sodium, rubidium, cesium, francium. Which one is smallest radius? Lithium, sodium, potassium, rubidium, cesium, francium. Which one has the smallest radius? Are you listening me? Which one has the smallest radius? Lithium in group 1 element, lithium, sodium, potassium, rubidium, cesium, francium. Among this one. Hello, are you listening me? Which one has the smallest radius? This lithium has 2 shell, sodium 3 shell, potassium 4 shell, rubidium 5 shell, period 5. So which one is the smallest radius? লিথিয়াম yes উপর থেকে যত আমরা নিচে যাব রেডিয়াস বাড়বে এগুলো রেডিয়াস বাড়তেছে তো লিথিয়ামের সবচেয়ে কম তারপর এখানে আমি যেগুলো বলতেছি তো গ্রুপের মধ্যে যেটা উপরে থাকবে এটা রেডিয়াস সবচেয়ে কম কারণ এটার মধ্যে দুইটা শেল আর পিরিয়ড 3 সোডিয়াম হলো পিরিয়ড 3 এখানে কয়টা শেল দেয়া 3 শেল পটাশিয়াম 4 শেল যত নিচে যাই শেল বাড়তেছে এখানে অ্যাটমিক রেডিয়াস বাড়তেছে সো লিথিয়াম ইজ স্মলেস্ট তো এইখান থেকে স্মলেস্ট অ্যাটমিক রেডিয়াস এই কারণে এটার মধ্যে অ্যাট্রাকশন বেশি ইলেকট্রন এইখান থেকে ইলেকট্রন সরাইতে বেশি কি লাগবে of the alkali metals in group 1 lithium sodium potassium rubidium cesium and francium lithium has the smallest atomic radius and highest ionization energy. Again of the elements in group 17 fluorine chlorine bromine iodine fluorine has the smallest atomic radius highest ionization energy. Now electron affinity topics এইটা দিলাম আমি এটা okay electron affinity look at this picture here this two first shell is 2 electrons second shell is 7 electron so it need gain 1 electron to form fill octet so it needed electron it need gain electron okay here is gain this atom want to gain electron so when an atom is gain 1 electron is released energy released when an atom gain electrons the amount of energy released when an atom gain electron is called electron affinity. Here electron is gained. Later one was electron removed. So definition of electron affinity: electron gain, the amount of energy released when neutral isolated atom in ground state takes up one electron to form a negative ion. This amount of energy released is electron affinity. So it gain electrons. For gaining electron to become negative ions, the amount of energy released is called the released amount of the amount of released energy is called electron affinity. Here electron becomes negative ions. Like chlorine in the gaseous state, it gain one electron to become negative ions. The amount of energy released to become one negative ion in the gaseous state is called electron affinity. Electron affinity. So electron affinity, now we see the trend. What happened? Trend. If we move from left to right, right to left, the energy emitted means released. The energy emitted when we try to transform an element in its gaseous state into 1 mole negative ion by injecting 1 mole of electron. Injecting means gaining 1 mole electron into its 1 mole atom is called electron affinity of that element. It is periodic property. In the same period, elements of the left hand side have greater left side have greater atomic radius than those the right side. When atomic radius is less, electron affinity is greater, and vice versa. So যদি less হয় electron affinity কি কম হবে। Next is electronegativity. We know two atoms turn into molecule by covalent bonds. The atoms in that molecule attract the electrons toward themselves. This attraction is called electronegativity. We know covalent bond. Now I didn't. This next chapter is bonding. We know this electron is bond is formed by sharing electrons. Like here chlorine. We know diatomic. The diatomic molecule. Here is a chlorine bond. Chlorine bond. His part. This one bond is formed by two electron sharing. Like here hydrogen, this hydrogen chloride, there is a bond. There is a hydrogen chlorine bond. This bond also formed by sharing two electrons, and two electrons. Okay, they are sharing two electrons. Each bond is formed by sharing two electrons or a pair of electrons. Here attraction between hydrogen and chlorine. Chlorine has more attraction to attract electrons. So here like this electron cloud here. So electron cloud will more to the go to the chlorine. Chlorine has attraction power is more, so attraction power of electrons more towards itself, so chlorine has more electronegative. It is a property of an element to attract electron to itself is called of that elements is called electronegativity of that element. So electronegativity is a property of element to attack electron towards itself. যার অ্যাটাক ইলেকট্রন করার ক্ষমতা বেশি তার ইলেকট্রোনেগেটিভিটি বেশি. When two atoms turn into molecule by covalent bonds, the atoms in that molecule attack the electron towards themselves. This attraction is called electronegativity. দুইজনের ইলেকট্রন কি তার দিকে বেশি টানে, একজনের কম টানে একজনের বেশি টানে, তার বেশি টানে, attraction is বেশি, তার attraction is called this attraction is called electronegativity. It is a periodic properties. In the same period, elements of the left side have greater radius, left hand side have greater radius in the same period. Same period like period 1, period 2, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon. So in a period, lithium has a greater atomic radius, less electron affinity, electronegativity, less atomic radius, more electronegativity. But this noble gases have no electronegativity. They don't share electrons, don't form bond, so they remain inactive. They don't share electrons, so so there is no electronegativity this element. So which the period 3, which elements will be more electronegativity? Period 3 elements is sodium, magnesium, aluminum, silicon, phosphorus, sulfur, chlorine. Which one will be more electronegative element? I said from left to right in a period electronegativity increases. I gave a clue already, I have given now. Hello student, unmute everyone. In a period like period 3 is sodium, magnesium, aluminum, silicon, phosphorus, sulfur, chlorine. I am giving clue you. If we move from left to right, electronegativity increase as atomic radius decreases. So which one is more electronegative? Sodium, magnesium, aluminum, silicon, phosphorus, sulfur, chlorine. Hello?
Sodium.
Huh? Sodium na.
Chlorine.
Chlorine. কারণ হচ্ছে ক্লোরিন কোথায় লেফট টু রাইটে গেছে, একদম রাইটে আছে ক্লোরিন। তো এই দিস এলিমেন্ট among this element chlorine size is atomic radius is least here, from among this, so chlorine has least atomic radius, so most electronegative here. But among whole periodic table, most electronegative element is fluorine, this one. Okay, তো শেষ হয়ে গেছে এটা। When two atoms turn into a molecule by covalent bonds, the atom in that molecule attract the electrons towards themselves. This attraction is called electronegativity. It is a periodic property. In same period, elements of the left side have greater radius than those of the right side. When atomic radius is less, the electronegativity is greater, and vice versa. For example, sodium atom is in the period 3 of the table, has the least electronegative attraction, and chlorine has the most. Okay, I am 4 minutes remaining. এটা এখানে